Hi, and welcome to my video on relations among trig functions, and we're going to talk about angles that are supplementary. Supplementary angles add up to 180. So I'm going to have two circles drawn here, and we're going to have a unit circle whose radius is 1, and we're going to have a rotation of theta from here, this point, and this point is 1, 0. So we rotate up to here, theta. So this is theta in here, but I'm going to call it in terms of the reference angle, which is equal to theta. And we have a perpendicular from this rotation of theta down to the x-axis. So this is x, this is y, and this is 1. Now, we're going to rotate. We're going to look at, if this is theta, then the supplement of theta. So if I have a theta, its supplement is 180 minus theta. So if this is, again, theta, and this angle here is the reference angle, so 180 minus theta would be this rotation right to here. So that's 180 degrees minus theta. Oops, do theta, not degrees. So this rotation here, which is theta, which is the reference angle, this is the reference angle. So we have a perpendicular. So this is the reference angle. That means this distance here is negative x. This distance here from this point, with the perpendicular, that's the y, and the hypotenuse is 1. So let's look at the relationship between 180 minus theta in relation to theta. So let's look at the sine of theta. The sine of theta, sine, here's theta in the reference angle. Sine is opposite over hypotenuse, so that's y over 1 or y. So let's look at the sine of 180 minus theta. So this is 180 minus theta is the reference angle, is sine is opposite, which is the y, over hypotenuse 1, which is y. So in terms of the sine of 180 minus theta is, in terms of theta, is equal to, the two of them are y's, so they're equal to each other. So the sine of 180 minus theta is equal to the sine of theta. So notice that in the first quadrant, the sine is positive. In the second quadrant, the sine is also positive. But notice that 180 minus theta has the same reference angle, so the sine gives you a sine. And also, let's look at cosecant. So cosecant would be the same because sine and cosecant are reciprocals of each other. So we would have a 1 over y, and the sine of 180 minus theta would also be a 1 over y because it's a reciprocal. So that means, oops, I said sine there, that's cosecant. So that means that the cosecant of 180 minus theta is equal to the cosecant of theta. So sine is positive, cosecant is positive, and they're the same because they have the same reference angles. And now let's look at the cos of theta. Cos is the adjacent over the hypotenuse, so that's x over 1, or x. What about the cos or cosine of 180 minus theta? So this is 180 minus theta here, the reference angle. So it's negative x adjacent is the adjacent over the hypotenuse. So that's negative x. And notice now that the cosine of 180 minus theta in relation to theta, again, the reference angle is the same, so we have, again, cos, but the 180 minus theta is in the second quadrant. Cos in the second quadrant is negative. Positive in the first, so it's the negative. Because the cos of 180 minus theta is going to be negative because in the second quadrant, then it has to be equal to the negative of the cos of theta, because the cos of theta in the first quadrant is positive. And also, the reciprocal of cos is secant. So the secant of theta is, again, reciprocal, so it's 1 over x. And the secant of 180 minus theta is right here. This is 180 minus theta is 1 over negative x, which is negative 1 over x. And again, they're the opposites of each other. So the secant of 180 minus theta in relation to theta is the negative of the secant. So cos is the negative, secant is the negative. That's the reciprocals of each other. And again, the function cos is a cos, secant is a secant, cosecant is a cosecant, sine is a sine. Because the reference angle is the same, the function is not changing. And let's look at tan. So the tan of theta, here's theta. Tan is opposite over adjacent. So the tan is the y over the x. So the tan of 180 minus theta. So let's look at the tan of 180 minus theta. Tan is opposite, which is the y, over the adjacent, which is negative x. So that's negative y over x. And so that means that the tan of 180 minus theta, notice they're the opposite of each other, so it's the negative tan of theta. And again, in the first quadrant, tan is positive. In the second quadrant, tan is negative, so it's the negative of the tan of theta. And cot is the x over the y. Cot is the adjacent over the opposite, so x over y. And the cot of 180 minus theta, the cot is, again, the adjacent, which is the negative x over the opposite. Adjacent is negative x over opposite, which is y. Notice it's negative, so the cot of 180 minus theta is equal to the negative of the cot of theta. So cos, if tan is positive, cot is positive. If tan is negative, cot is negative. So note, in relation to 180 minus theta, the function, whatever you have, is not changing, but it could be plus or minus. Everything is positive in the first quadrant, so what is cos in the second? Negative. What's sine in the second? Positive. What's tan in the second? Negative. So that is doing 180 minus theta. And just as an example of that, let's do two examples. Let's look at the sine of 60. So let's rotate 60 degrees up here. So let's say that's 60-degree rotation. We drop a perpendicular to the x-axis. Terminal arm goes out through that rotation, perpendicular. So this angle in here is the arc. The measure of the arc is equal to the measure of the central angle. So this is the 30. And rather than use a unit circle, I'm going to use the special right triangle, which is the hypotenuse is 2, this is 1, and this is root 3. And everything is positive in the quadrant, so the sine of 60, sine is opposite over hypotenuse, so it's root 3 over 2. Now we're looking at 60. 60 is the same as 180 minus 60. So that's the same as the sine of 120. And the sine of 120, well, we'll rotate here. 120 is, let's say right to there. That's a 120-degree rotation. Drop a perpendicular to the x-axis, and there's your terminal arm. So that's rotation is 120. That means this arc is 60. So this angle in here is 60. That means that's a 90, so that's a 30. And again, we have a hypotenuse of 2. This is opposite 30 is 1. Opposite 60 is root 3. The x is negative, and the y going up is positive. So the sine of 120 is the same as the sine of 60, which is a root 3 over 2. So that means, just as an illustration, the sine of 180 minus theta is the same as the sine of theta. So 120 is 180 minus 60, so I'm just using this as an example. In the first quadrant, sine is positive. In the second quadrant, sine is positive. And because we're again rotating 180 degrees and 180 minus 60, we have the same reference angle each time. So it's a sine, sine, and they're positive. What about a tan? The tan of 30 and the tan of 180 minus 30. So 30 rotation, let's say, is right here. Terminal arm to that rotation, perpendicular to the x-axis. So the reference angle is 30. So this is a 60. Opposite 30 is a 1. Opposite 60 is a root 3. And again, the triangle, the circle is going to have a radius of 2. I use this circle, I use this triangle because it's easier. For instance, if I use a unit circle, which is 1, made the hypotenuse 1, this would have been a 1/2, and this would have been a root 3 over 2. But I like, when I use tan, I like the triangle to be 1, 1, root 3, and 2. So the tan of 30, tan is opposite over adjacent. So opposite of 30 is 1, adjacent is root 3, multiplied by root 3 over root 3. So that's root 3 over 3. And 180 minus 30 is the same as the tan of 150. So we rotate 150 degrees. We rotate right to here. There's 150, 180 minus 30. Terminal arm, perpendicular. So the two triangles are congruent. So this angle, this rotation here, this arc length is 30, so that means the central angle is 30, and this is 60. Again, notice with 180 minus theta, the reference angles are the same. So this is a 1, this is a root 3, this is a 2, the y is positive, the x is negative. So the tan of 150 is opposite, which is 1 over negative root 3, opposite over adjacent, and multiplied by root 3 over root 3. So we have negative root 3 over 3. And again, the tan of 180 minus theta is equal to the negative tan of theta. Because the reference angles are the same, 30, 30, tan is positive in the first, negative in the second. And how I know that? Because I developed add sugar to coffee. Add sugar to coffee. This is all sine, tan, cos. So everything is positive in 1. Sine is positive in 2. Tan is positive in 3. Cos is positive in 4. And if sine is positive, that means cos and tan are negative. If tan is positive, that means cos and sine are negative. If cos is positive, that means sine and tan are negative. So what you see is positive, what you don't see is negative, except in quadrant 1, they're all positive. So that's the review of the supplementary angles of 180 minus theta. And again, if you like my video, click the like button, click the subscribe button if you want to subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.